In this problem, we want to apply the mean value theorem to a function on an interval and find the values that satisfy the conclusion of the theorem. So in order to use the mean value theorem for a function, the function itself has to be continuous on the closed interval involved. So that's the closed interval 0 to 4. And it also has to be differentiable on the interior of that interval, which is the open interval from 0 to 4. So the first question here is essentially, does the function f of x equals the square root of the quantity 2x plus 1 satisfy the hypotheses of the mean value theorem? Is it continuous on the closed interval 0 to 4? And is it differentiable on the corresponding open interval from 0 to 4? And then we maybe want a little bit of explanation. So the continuity. A square root function is continuous as long as here we have an inside function, as long as that's continuous and positive. Or actually, it could be 0, so I should say non-negative. So 2x plus 1 is continuous everywhere, and it's non-negative, so greater than or equal to 0, if x is bigger than or equal to negative 1/2. So our polynomial 2x plus 1 is continuous everywhere, and the square root of it is continuous if x is bigger than or equal to negative 1/2. So f of x is continuous on the interval negative 1/2 to infinity, and so it is continuous on the subinterval from 0 to 4. Then the differentiability, the derivative of our function is, we use the chain rule, the derivative of the square root is 1 over 2 times the square root, leave the inside in, 2x plus 1, and then times the derivative of the inside, which is 2. We can cancel the 2's. Our derivative is 1 over the square root of 2x plus 1. And this is defined as long as 2x plus 1 is strictly bigger than 0. So it is defined if x is strictly bigger than negative 1/2. And so that means we have a derivative. Our function f is differentiable on the interval from negative 1/2 to infinity, and so it is also differentiable on the smaller interval contained inside 0 to 4. So these two conditions tell us that the mean value theorem can be applied to this function on this interval. And the mean value theorem says that there will be a point C in the interval, in this case between 0 and 4, such that f prime of C is equal to f of b minus f of a over b minus a. The slope of the tangent line is equal to the slope of the secant line. In other words, the instantaneous rate of change at some point is equal to the average rate of change. So first, let's calculate this number, f of b minus f of a over b minus a. So that's f of 4 minus f of 0 over 4 minus 0. F of 4 is the square root of 9. 2 times 4 plus 1 is 9. The square root of 9 is 3. And f of 0 is square root of 1, which is 1. And of course, 4 minus 0 is 4. So we get 2 over 4, which simplifies to 1/2. So this number, f of b minus f of a over b minus a, is 1/2. And so the theorem says that there should be a solution to the equation f prime of x equals 1/2 somewhere between 0 and 4. So we already calculated the derivative. It's here. It's 1 over the square root of 2x plus 1. That's equal to 1/2. So taking the reciprocal of both says that the square root of 2x plus 1 is equal to 2. Square both sides. 2x plus 1 is equal to 4. So 2x is equal to 4 minus 1, which is 3, and x is equal to 3 over 2, which is between 0 and 4. So there is one point in the interval 0 to 4 where the slope of the tangent line is equal to the slope of the secant line, and that happens when x is 3/2.